Hey, this is Sri.
And this is Will.
Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Will?
It's going all right. How about you, Sri?
Pretty good. You look like you're in a fancy office/hotel room.
Yeah, I was going to say fancy bathroom because it's a little strange that there's like a glass door behind me, but whatever.
Yeah. You got any interesting drinks from Whole Foods this week?
Well, no. So I went to an Asian grocery store and I have organic aloe with 50% more aloe.
Oh, nice.
It's really just a lot of sugar with some pulp, honestly. Like the stuff I put in my body for the show. And then I also went to a place called Pho Papa for some mung bean smoothies. And so it's in San Jose, if anybody cares to visit the area.
Very cool. Representing the Asian food this time.
South. S.
It's reversed.
Yeah.
Oh, okay. There we go. Very cool. So I've got a hot toddy, which I have mixed this hot toddy syrup.
What is a hot toddy?
A hot toddy is basically a lemony. It's a hot drink with lemon, honey, sugar, ginger, cinnamon, and cloves. So this syrup from a small farm in New Hampshire.
Wait, is toddy a type of drink or is it the brand name?
I don't know what a toddy is, actually.
Yeah,
because there's no normal toddies.
Honestly, I was watching Downton Abbey this past week, and I think somebody mentioned toddy as well. I was like, I don't know what they're talking about.
Yeah, I don't know. It's my first time.
We'll look it up. Maybe it'll be in the show notes, but maybe not. I don't know. Anyways.
Yeah, there you go. So I've got that mixed with a little bit of this Boston rum. So I guess I'm representing the Northeast, I guess. I'm a Northeast boy now.
Yeah, Boston. That's right. Boston. Yeah, so what are we talking about this week?
So this week we're talking about our first AI topic on this podcast.
Yeah, clap, jazz hands.
Yes. So we've done a lot of hype with crypto and hype with web dev, and so now it's time to move on to the AI hype train. Right. Specifically, we are talking about two machine learning models that came out of OpenAI earlier this year in 2021.
And OpenAI is real quick is just a research group that was funded by Y Combinator, and they do a lot of interesting work in AI, and Sri is a better judge of me than whether it's innovative work or not, but we'll talk about two of theirs today, which is called Clip and DALL E. And so you were saying, Sri?
Yeah, so Clip and DALL E are very interesting because they are multimodal machine learning models. This is just a fancy way to say that they both take in two different types of inputs, specifically in the case of Clip and DALL E, text and images. And what they do is that Clip is an encoder framework that takes in images and maps them to a latent space, to a vector space, as well as text and maps them to a vector space. And the interesting thing is that these two, it's able to map images and text to the same vector space such that if you have an image of something and you have a text of its description, the resulting vectors from the two encoders should be the same or very similar. So to get concrete, let's say that you have an image of a dog in the park. The image encoder will map that to a vector. And if you have the text, a dog in a park, and you pass that into the text encoder, it will also map that to a vector. And these two vectors will be very, very similar to each other or the same. And so what this allows you to do is it allows you to compare text and images with respect to each other, which is something that you really weren't able to do before. Or there might have been prior work able to do it before, but Clip is able to do this at a massive scale because it learned these correlations from a massive data set collected from all across the web.
So hold up, right? As they would say on the internet. So what you're able to do now with Clip that you weren't able to do before is if you have the description, the text description of a concept, you can convert that into a vector in some abstract latent space of concepts. It's like a high dimensional space of concepts. And then you can remap that vector into an image, or at least you can compare an image and the description of something and see if they're the same.
Yes.
Okay,
that's what
so
you can do.
right. So you always have to go from the text and the image to the latent space. You can't go back out the other way, right?
Yes. So that's the case with Clip.
I see, and we'll get to the other one. But so to sum up Clip, like concretely, what you're able to have is, given the description and given a picture, you can tell if they're really describing the same concept or not now, right? And it's like you can mix and match media now with the Clip, right?
Yeah, totally.
That's pretty interesting. And then, so what about DALL E?
Yeah, so DALL E is more along the lines of what you were describing. So DALL E is another pair of models which goes in the direction of taking a piece of text and then being able to generate an entire image from this. So this is very, very interesting, because rather than simply mapping these two things into a shared latent space, you're actually able to generate novel images. And so
generate novel images by writing text, right? It's kind of like a strange thing where I guess I've read it described as a steering the image generation with text. It's almost like it's the dream of programming, I suppose, where you basically just describe some scene and like this painter paints it for you in whatever way that it knows how, right? And then you can iteratively update your description of what you want to have it draw, and it'll just keep generating them. Is that correct?
Yeah, and the interesting thing is that it's learned a correlation between the text and the output concepts such that you're able to compose them in novel ways. So we can go into this when we do a little demo or do a screen share, but you're able to say, generate me an image of an object with a texture that it normally wouldn't have. So the famous example is that they said, generate an image of a chair that is like an avocado, or an avocado chair.
Which so we know, as like humans living in the world, that there's the market for an avocado shaped chair is probably next to zero. So therefore the product probably does not exist, and hence marketing like imagery of the thing shouldn't exist. And yet when you look at it, that's exactly what it looks like, right?
Yeah, it looks exactly like how if you commissioned an avocado chair for your avocado startup, like it would look like that. And so yeah, I think obviously that's nowhere in the training data. And so what's clear is that somehow in its massive training phase, these models have learned what it means to be a chair and what it means to be avocado shaped, or to be an avocado. And basically it's able to compose these in a novel way to generate something that is reasonable and sensible to us, at the same time novel.
That is really interesting, because for a long time the natural language processing and the computer vision people have been hand tuning their like feature extraction phase and trying to map it to something. And I feel bad for those PhD researchers and students, because like all that work is just wasted time, because this works so much better. Like however it is mapping to the latent space, like the latent space somehow represents concepts in which the concepts are arranged in a spatial way in a high dimensional hyperspace, I guess, where you can compose them together, so that if you ask it for a fuzzy banana, it knows what fuzzy and it knows what banana is, and it's able to generate a fuzzy banana rather than just banana and a patch of fur, or like in the wrong place, or something that doesn't look quite right.
Yeah, exactly. So I think the main advantage is obviously both of these models are trained on massive data sets. So I believe that DALL-E at least was trained on 250 million images from the open web, and I think Clip either use the same data set or at least a similar concept. But so they're trained on massive data, and they have architected these models so that they learn these high order concepts rather than simply overfitting to the details of their training data. So
Right.
they generalize in an interesting way rather than simply memorizing all the data that they've seen.
Yeah, overfitting is effectively a way of saying memorizing, because like a lot of these neural networks are trained with data, and one way to pass the test is you just memorize all the answers, right? Match to the question. And so ideally, the training data is different than the test data, so that you can test if the neural network has actually learned a generalized version of the concept you were trying to by showing it examples rather than just memorizing everything. And so it's like previous neural networks seem to be able to somewhat generalize, but maybe in ways that seem like it still was a little bit patchy. I think like Deep Dream was one way that people were trying to figure out like how a neural network encoded different concepts. And so it was like a strange psychedelic mishmash of things. Like if you ask it to like, oh, what is an arm? And then like try to like boost the neurons that would generate an arm picture, it's kind of this nightmarish picture of like arms and elbows and half arms and stuff like that. And so people have used that to kind of figure out the concepts. But it sounds like in Clip, like it isn't quite that. It's like somehow in the latent space, like we can't really draw a picture of it, but somehow it's related in a way where you can compose these things, whereas the previous latent spaces didn't quite have that property. Is that correct?
Yeah, I think so. Definitely the generative ability of DALL-E is, I'm not sure if there are official metrics for how to measure how good the output of these types of models are, but it at least subjectively seems to outstrip any of the prior work that I had seen. And similarly, Clip does a very good job of mapping text and images to a similar latent space. And the primary use case that they're able to evaluate this for is for creating classifiers. So you can basically take Clip and pass in a description of the thing that you're trying to classify. For example, you want to say, I want to create a classifier that finds images of airplanes, and then you're basically able to just use natural language to instantiate such a classifier, and then pass in a variety of pictures, and it will be able to detect with a good amount of accuracy pictures of airplanes just from a natural language description that you passed it. You didn't have to train, you didn't have to go and collect a bunch of training data of things that were airplanes and not airplanes. All you do is you just take Clip and you pass it a piece of text, and now it's able to match that against images. And if the images output a vector that's close enough to the vector of your text description, it will say it's a match. And they were able to run various benchmarks for which it was able to classify things with a high degree of accuracy without any further training.
Oh, I see. So, I guess let's pull up an image from the blog post by OpenAI on Clip to show our YouTube viewers like what we're talking about. And so instead of the airplane example you gave, I think they're talking about bananas, right? And so my understanding is typically if you train your neural network on one set of data, such as like ImageNet or something, like it's generalized, but like it doesn't then subsequently do so well on other image data sets. So each one of these is a different data set, like ImageNet, ImageNet v2, and you can see that they're focused on different things. Like for example, ImageNet rendition are kind of like abstractions of bananas, not actual pictures of bananas. And so my guess is typically like older neural networks had a more difficult time classifying these abstractions of bananas, right?
Yeah.
And so you could see that like the old ImageNet ResNet 101 like scored 37.7% on this, but it sounds like Clip was able to generalize the concept of bananas not just within the data set that you trained it on, but across like any other data set. And so that really lowers the cost of training new neural networks for a different purpose, but with the same concept. Is that right?
Yeah, so it shows that it's able to adapt. So Clip is able to adapt to a variety of inputs, and basically it's understanding, so to speak, of banana, the way that it represents the concept of banana is sufficiently generalizable that it generalizes across a realistic photo of bananas, a sketch of bananas, banana plushies, as well as various other ways in which you might see banana in the real world.
Right.
And so the advantage here is that if you, for example, wanted to sift through millions and millions of images that may have pictures of bananas, you don't have to worry too much about whether the image is cropped correctly, lit correctly, does it look like the kind of training data that was available in ImageNet or whatever standard training set that you might train an image classifier on. You're able to take Clip and just give it a vague description of what you're looking for, and ideally it should be able to detect it regardless of whether the distribution of your photos is very similar or different from the distribution of ImageNet.
Yeah, that's pretty interesting, especially the very last data set, which is the ImageNet adversarial, which is a data set that tries to throw off your neural network from its training data. So like, for example, this first image is an image of a banana, like with foreshortening and removal of all color, right? But it still managed to recognize that as a banana. And then like banana held long way so you don't see a curve, or like it's cut up like this. And so yeah, you can see the original image ResNet did terrible on this, 2.7, and it's impressive that Clip scored 77, which I think is second highest score across all the different data sets, right? Even though it's adversarial. That's pretty impressive. So at the end of the day, I mean, like this just makes it easier and easier to train neural networks, because now only the first person training Clip has to bear the cost of the massive training data. Everything else it's almost like you can parameterize the resulting model, like neural network model, to focus on what you want to look for, right? Is that right?
Yeah, basically. And so if you actually go lower down on this page, you can see the comparison across a variety of tasks. And so basically in the world of image processing, you might have in the past had to train a detector that is focused on object detection, and then another one for healthcare use cases, another one for some type of satellite imagery, et cetera, et cetera.
Yeah.
Now, what this graphic shows is that for all these variety of tasks, they were able to apply Clip to each of those tasks, and it seems to fare fairly well, in that even though Clip is not a for example, a
food identifier, right?
food identifier.
Yeah.
It's able
Like
to,
like in Silicon Valley, where what's his face, Jimmy O Yang was making the hot dog identifier, and then I guess he must have used Clip because they were able to use it to identify porn.
Mhm. Yes, yeah. So yeah, like now you can just take Clip and solve, an arbitrary task, and it does pretty well for a model that was never trained specifically for that purpose. Now you can see here that it does well for food identification. It does well for, I don't know, identifying this television studio. It doesn't do perfectly for things that it hasn't seen. For example, it isn't able to rank correctly that this picture of annual cropland
Mhm.
is annual cropland.
Yeah.
So it ranks it lower, but it ranks it, I don't know, relatively high compared to the other things. And so at least it's interesting that for a model that was not purpose built, it's able to do fairly well. You
Mhm.
might want to use this as a first pass classifier, and then maybe take take its results and pass them for human review. And so, for example, if you were trying to flag, let's say, some type of, again, porn content or some other kind of content, you might maybe put Clip in front of your huge stream of data and have it cull down the images to a reasonable size, and then give it to a human moderator queue and make their job easier. Or maybe you pass it to another different machine learning model that's more expensive to run, or whatever it is. But it's kind of impressive that it's able to do well on these tasks, even though it was never trained for this purpose.
That's pretty cool. Do you know how they came? People at OpenAI, was it the brainchild of one specific person that had an insight, or was it, I guess, a team effort?
I'm guessing it's a team effort. I think the paper has
A whole
many,
bunch
many
of
authors.
authors. Okay, yeah. I didn't
Yeah.
know whether it was a specific insight, but yeah, like I was thinking, oh, if I came up with this, I was just like, it probably never work. But then I guess you just have to try it, right?
Yeah, and I think it's the 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 secret sauce of OpenAI just seems to be very, very huge, massive data sets combined with clever engineering to make sure that they're able to train on these massive data sets. And so they do very good engineering work about distributed training, making sure that they're actually able to handle this huge data.
Mhm.
Whereas maybe other labs with fewer resources, especially fewer engineering resources, might settle for paring down the data set just to be able to get a model trained.
Yeah, I see. I guess they should have just called themselves Go Big or Go Home. So,
Yeah.
and then
So
so then this is Clip, like what Clip can do. So in summary, it generalizes well across different data sets, and like we showed examples of images, but like you could do the same with the text, because like you said earlier, it's multimodal. So like you could have a text model that was originally trained on something else, but then it would be very good at picking out information from other types of data sets with the same topic, like the same concept, from other different data sets with different like statistical distributions, right?
yeah, I think so. So I think they haven't shown examples, but I'm sure that that could be the case.
Mhm.
And so yeah, I think there are some interesting projects that are making use of Clip. So actually, maybe we can go into that before
Right.
we go to
To DALL-E.
DALL-E.
Okay. So this is a same dot energy,
Yeah,
and free. What can you tell us? Like, what is this?
yeah. So basically, this is a semantic search engine that is powered by a machine learning model, which is similar to Clip. I don't think they're using Clip exactly, but they're
Mhm.
using a very similar machine learning model.
Mhm.
And what it allows you to do is that if you click any one of these images, it will pull up something that is
Sim.
stylistically very similar to the image that you started and you seeded the query with. So I don't know, pick something that looks fun. It actually works really well, so you don't have to worry too hard about which thing you pick.
Oh, I see. Well, this immediately caught my eye. This giant balloon thing.
Okay, let's click it. All right. All right. So it kind of found other images in which there is some kind of hallway with a big yellow orb type theme.
Right. You can see that there's a thematic aspect to it where it picked the ones with the hallways with the fluorescent thing, right? And so I guess if I pick something else that I don't know, like
pick the sketch guy, I guess.
Yeah, like we should see other sketches that are similar thematically. And so does this allow you to wander the space, or does it let you narrow things down? Like,
so I think same.energy is very good about giving you like not exactly what you search for. There is some variance here, but it is fairly narrow. And so I have had a hard time kind of getting out of
I see, yeah,
the thing that it's taken me. Although maybe if you click like this Japanese looking one, now you've got into this like Japanese area of the vector space.
Because I guess I didn't know whether it saved the idea that both it was a sketch and it's like Asian, but it looks like it is, because like I don't see any like Western looking sketches here. As a result, so like once you click a couple ones in, you narrow it down pretty fast, which I think is useful for a specific type of task, right? Because this is the kind of like human AI symbiosis that people have always talked about, where the human is the seed, like the seed or the person that's directing the creativity of the AI, and the feedback from both helps the human AI pair come up with something creative.
Yeah. So, and this is powered by Clip or a Clip-like model in the sense that these are images from the web that might have a caption attached. Like, let's say, I made a sketch of a samurai or something like that.
Yeah.
And so it's when during the training, it's learned the concept of sketch and samurai, and learned to put images of that type close to each other in the vector space. And now if you give a query image, it's able to pull out all of those other images. And because they were trained in this clip-like way, they are semantically similar. They have some characteristics between them in which you can, even if you're not able to quite put your finger on it, you can say, oh yeah, could these images go together? Because probably they map to an area of a vector space that represents some concept. Here it looks like it's like aerial shots of European villages.
Yes, European villages. Are these real images or are these generated images?
These are real images. So yeah, these are from the web. Yeah.
Actually, maybe we can talk about this part in the second and third order effects. I was thinking that this is also interesting because if you could train public speakers text, then like given what somebody is saying in real time, you can hone in on like what other people or what other phrases people have similarly said and be able to pick those out as well. That would be interesting, because like as somebody is speaking, you could do something like that. Or I guess like baseball stats. I always wonder how they pull up those weird baseball stats. Wow. I mean, I'm sure there's like a non-AI way to do it, but this is the kind of thing where it reminds me that, if you in real time, you can find something similar, right? The same energy per se to whatever it is that you're currently hearing or seeing. That's pretty interesting. And it only takes like 2 or 3 clicks to kind of narrow things down.
Yeah, it does a pretty good job of basically finding some similarity, some characteristic, even if it's something that you're not able to really express. And so this is a cool project, again powered by this clip-like idea of mapping things to a vector space. So yeah, you can think of Clip as being able to create classifiers, being able to create semantic search engines, basically being able to take a query, map it to an input vector, and then pull out similar things around it.
Oh, I got out of that local area. I was looking at waves, and now I'm looking at the moon.
You're looking at the moon over water.
Yeah, moon over water. Can I get out of moon over water? Oh, I guess this one is markedly different.
That one is just a water. Now you
Well,
have like sailboats.
Sailboats, but it's still water. Can I get out of water? This is like it's like that Wikipedia game where you're traversing, but here I'm just trying to get out of the local space. But yeah, okay, that's pretty cool. This is what a clip like model would allow you to do.
Yeah, exactly.
Okay, so this is a clip. Shall we move on to like what DALL-E can do?
Yeah, so DALL-E is really, really interesting. And so actually the one thing that I will add is that Clip has been open sourced. So OpenAI has released the model. They have released the weights. So you're able to take Clip as it is used by OpenAI and download it yourself and build all kinds of cool stuff with it.
That is good. That's really great to hear. I guess the source code is on GitHub or something, and you just run it as a notebook.
Yeah, exactly. And people have been experimenting with it. We can go into some of the even more interesting experiments that people have been doing with it. But Clip is open. Now, DALL-E is very, very interesting because it's this generative model. Basically, what it's able to do is take the text of a text prompt, and then generate an entirely novel image with it. And this is even more powerful than Clip. And this model is not open source yet. Maybe it will be in the future, but at least for now, it's not. But let's take a look at some of these examples. So, like we mentioned, we can see this armchair in the shape of an avocado, and actually does a really good job. Like each of these designs is its own twist on what it means to be an armchair in the shape of an avocado. Different styles, different types of chairs. Very, very interesting. And
I look at it and I don't know, when I first saw the image, I'm like, I kind of want one. Although I know it'll clash. And so the implications, I think like a lot of people would jump immediately to a lot of different things, at least for the illustrations of the radish walking the dog or the daikon walking the dog above. I can totally see it, because anytime I'm making landing pages, one of the things that I always have trouble with is what image to pair with it. Like, and honestly, like, I'm just testing out ideas. I don't want to pay somebody on Fiverr to like create these things for me. And so having something like this would be really interesting, because then it removes the need for an illustrator just to sketch out an idea, at least in the near term.
Yeah, I think so. And similarly, in the case of this armchair in the shape of avocado, now, maybe not too many people are in the market for this, but if you're a design company, let's say, that is exploring the space and you just want to riff on some ideas, maybe just to get inspiration, maybe to get an idea of the different shapes that you could use, not to make literally an avocado chair, but just to pull some inspiration from there. You can kind of work with this AI model. Like if you had DALL-E and you gave it some prompts and you saw like maybe some of the creative ideas that it's coming up with, and you can take those and you can refine them. You can make them, more palatable or clean them up a little bit. But it's almost like working in tandem with this machine learning model in order to harness its creativity.
Yeah, I mean, I guess you don't need to take LSD anymore or like smoke some weed to get some inspiration. Like you can use the DALL-E model to help you with the exploration of space. That's pretty interesting.
Yeah, so I think DALL-E is also interesting because, like we said with the armchair in the shape of avocado, that's probably not in the training set. But also similarly with these illustrations, this radish walking a dog, it's learned that maybe the radish that is walking a dog, it should look like a anthropomorphic radish. It's not like literally a picture of a daikon,
Right.
daikon you'd find in the
Yeah.
store. It's
Yeah.
added some eyes to it. It's learned some interesting concepts.
Right. And that single word illustration is able to affect stylistically the whole image rather than specific parts of the image too, which I think is pretty impressive.
Yeah. So DALL-E is very, very interesting. So one thing that the community has done in order to adapt to the fact that DALL-E is not open source is that they have kind of hacked a version of DALL-E, not in the sense that it's literally the DALL-E architecture, but they've taken Clip and they've combined it with these other machine learning models called GANs, which are
what do they stand for our
generative adversarial networks. We don't need to go into we don't need to break it down, but basically these are neural networks that take in an input vector and then are able to generate an image from them.
There are neural networks that generate images, and that's a generative part in the name. And then the adversarial networks is just how they are trained. So
yeah, so these are the types of networks that power things like this person does not exist, and these kind of websites where they're able to generate actually very high quality versions of faces or illustrations and things like that. And so that's a funny looking face. So actually what's interesting is that people have been experimenting with taking certain GAN architectures and then using Clip to steer them in the similar way that DALL-E works, so that you take a GAN, it outputs an image, and then you take Clip and you say, is this, you give a Clip a description, and then you say, is this image similar to what Clip is expecting? And if it's not, then feed that back to the GAN and have it move around in latent space in the direction that makes it closer. And you do this iteratively, and eventually the GAN will move around in latent space and generate an image which matches the description of what you're looking for.
Wait, so the GAN normally takes like a latent vector as an input after it's been trained, and it generates an image, right? And so once it's already trained, is the Clip encoder already trained as well? And so you use that to steer? Okay, so like because Clip is trained on a completely different data set, we already established that it doesn't have to be trained on the same data set as the GAN, the generative adversarial network. So like you just take it as is and plug the two things together, right? The input of Clip is a description, its output is the latent vector, and then the input of the GAN is a latent vector and its output is an image. So when you hook those two things together, you're able to effectively attach a steering wheel to a car in which the car generates images, I guess. And like because our computers have keyboards that enable us to type words, like Clip is effectively like it's chaining your thoughts to the keyboard, to the text description, to the latent space, to the image. And so that's the chain of translations that allow you to type words and generate images. So you're painting with your keyboard effectively.
Yeah, pretty much. So actually we can look at some of the outputs of that. Okay, so here's an example of a prompt over here at the bottom. So cyberpunk forest.
Cyberpunk forest. Yeah.
And this is the image that the GAN output, which, it definitely has a forest quality to it in that, the middle part looks kind of bushy like a tree, and it definitely has the qualities of cyberpunk, whether it's the color palette or
it's very neon and dark and gritty. Yeah, that's pretty cool. Although, like, zoomed in, you can tell like a lot of the micro details don't quite make sense, but these definitely look pretty good when you zoom out, right?
Yeah, so it definitely looks good zoomed out, and again, you can add modifiers. So this is Cyberpunk Forest by Salvador Dali, who's a artist that does surrealism style.
And right. You've seen the painting of the melting clock or the melting stopwatch, and so that's Salvador Dali, where like he's playing with, I guess, perceptions of reality, and so here is in style. Do you see any meltiness? I'm not familiar with his.
It's definitely like curvier, I guess, like
than the other one.
Yeah,
the color palette's definitely different, right? So
yeah, definitely, and the interesting thing, because Clip was trained on images from the web, it's learned certain quirks of the web. For example, there is a website called ArtStation HQ, which, or maybe it's a subreddit, but basically it's a token which it has learned means make images, or rather it should match images that are of a certain high quality illustration style. And so when you attach it to the GAN, if you add the token ArtStation HQ, what it means is make an image which is even more maybe high quality looking and less grainy than the other one. So like over here, the original one, Cyberpunk Forest, was a little bit grainy, like you mentioned, a little bit incoherent. But if you attach ArtStation HQ, there's a little bit of a different feeling to it in that it looks a little bit like the richer color palette.
It's more painterly here. Like I can see where like it looks in the middle part where it looks like there's a shadow of a guy with a backpack standing on a brick wall. It does seem a little bit more, what's the word, oil painting like, at least that color palette over there.
Yeah, exactly. And you can do other things as well. Lastly, like I'll say, you can add other modifiers. So here you can attach this thing saying green and white -1. So you want a picture that doesn't have as much green and white on it. And here we have, again, the result is definitely less green and less white, and more using other colors. So it seems like the machine learning model has learned this idea that you can add these modifiers, and it seems to do pretty well.
That's pretty neat, huh? So then, what else can you show us about DALL-E? Is this all you had for like pictures?
Yeah, that's all I had in terms of pictures. But so I guess I'll underscore the fact that DALL-E is not readily available, but people have taken Clip and sort of attached it to other off-the-shelf machine learning models and are doing all kinds of interesting generative art. And so it seems like the fact that that Clip exists and is so readily composable with the rest of machine learning models means that there are probably combinations of and applications of Clip that we haven't seen yet, whether it's for generative art or maybe combining with even other different types of machine learning models. And so yeah, I think like there's a lot of creativity to be explored still.
That's pretty interesting. And then so then I guess, where do we go from here? Like, what are I think we outlined at a high level like how Clip is able to achieve this thing. Basically, the key core point is that if you can map the encoders to the same latent space, and that latent space is pretty good at representing concepts, then you're going to have this power that has been exhibited. And you can imagine any type of medium that we have that we can digitize, we can write an encoder for it, like whether it's text, visual, audio, even video, I imagine is a sequence of images, and that should be doable, right? I guess even other things like maybe interpretive dance, perhaps.
Yeah.
But if interpretive dance is ever consistent, I guess. but that's the idea. It's pretty interesting. So what are the sort of things that people are doing today with it? Because I can see when we went over it, like what's new about it, or like what's new. And so one example of what people are doing is with the same energy, the visual search, but that seems to be more of a demo than like a production level thing. Like, do you know what people are using it for today?
Same energy, or
no, just Clip and DALL-E. Obviously, DALL-E is not open source, but say Clip.
Yeah. So the biggest use cases that I've seen are in this GAN plus Clip space. And actually, there's a really interesting project which combines this GAN plus Clip with crypto. And so what they've done is that they have created a DAO.
You just have to wait for it. Let's how many minutes is it like that before we got there?
Yeah, well, not as early as in this episode as we thought.
Right.
But yes, so there's a DAO in which people vote on which direction to steer this Clip plus GAN combo.
Oh, that's interesting. It's kind of like Twitch plays Pokemon, but with DAOs, right?
Yes, exactly. And so they steer this thing, and it generates images. And then I think their idea is that they're going to, once they're satisfied, mint that image as an NFT, which people buy. So we haven't actually covered NFTs on this podcast yet. But
we're waiting for the hype to die down before we really get into the meat and potatoes of it, I guess.
Yeah, exactly.
We're either ahead of the curve or behind it, but never on it.
No, because if we were, it would mean that we would actually go make something and
too mainstream. Yeah, too mainstream, too successful, and that would not be hipster enough. So
yes,
we'd be drinking water and Corona if that on the show if that were the case.
Yeah. So basically, this, I think it's a good way that you phrased it. It's kind of like Twitch plays Pokemon. It's basically DAO plays the art. And so eventually they want to create what they're calling an AI painter, which is steered by this committee, and then sell the art that it generates for money, which then flow back into this DAO, potentially making the DAO members richer, or maybe feeding back into training more advanced GANs to generate even better art.
You know what's the name of the DAO that's doing this?
I'll have to remember it.
Okay, that's fine. Yeah. No, because I was thinking like maybe instead of NFTs and art, it's a little roundabout way. Like, why not have a DAO that uses Clip to generate landing pages to sell products? Because you could technically do that. Like, because I mean, drop shippers are always like looking on the drop shipper subreddit. They're always looking for products that would sell well, and always asking around. and they would then buy the stuff either from Alibaba or somewhere else and just list it on Amazon and pocket the difference. And the DAO could conceivably either generate landing pages that find, like, so maybe for a specific category, like, I don't know, cufflinks or something. Like it finds the optimal landing page that would generate the most sales for different kinds of cufflinks. Like you should be able to at least generate like different versions of it, right? Because then you could write a description. Like the DAO could decide like what should we sell, and then once they do that, then they write the description, and the clip would then generate a web page. Well, it would, I guess, go into the latent space, and then there would have to be something that takes a latent space, to a landing page, and then that would deploy that, and then I guess the sales number would then feed back, I guess, into like back propagate to see how well. I do wonder if that's enough of a signal, because usually for e-commerce, like a good e-commerce sites converts like 4% of the time, and like, and that's considered good. And so I wonder if that's not enough feedback for a neural network to tell whether it's doing a good job or not. You'd have to have pretty high volume driven to a page for that to work, I think, but it is conceivably possible, I guess.
Yeah, I mean, I think that'd be pretty cool. Or it deploys two versions and then A/B tests them and learns something about, again, feeding back into the model. It learns how to make better web pages. That would be really interesting. Another one that I was thinking about is that you could do the same thing for audio. So again, if we take this idea of clip, let's not constrain ourselves exactly to the modes of text and images. I think if you broaden the perspective like you have been doing and say, let's not think of clip just in its current iteration of mapping a distribution of images and text together, but rather any two modes of input, then you could apply it with other things, like, let's say, taking a description of a music that you want to generate and then attaching it to a music generator model and then steering it that way. So let's say that you have an idea for a song and you want to generate a music that has a certain type of beat and a certain type of instrumental. You might be able to, in the future, write a natural language description of that and then attach it to the music generator and then get back at least a sketch of a song and then build on top of that.
Yeah, that's really interesting, because I know one of the things that movie composers complain about, movie directors, is that before a movie is finished, a movie director will want a placeholder in the score of the movie, and usually they use songs or scores from other movies, right, as a placeholder. But then because they're like watching it so many times in editing, that they get used to the idea of, okay, this is what the scene should sound like, and then they just go to the movie composers and say, just give me the placeholder, but like, we can't obviously use that one, just give me something similar. And they're just super frustrated about that, because like, why am I even in this job when you just want the same thing? And so like, a lot of the movies have really forgettable scores because of this kind of dynamic that's going on. So you could conceivably have movie directors that need a placeholder. Like, it may not be the final thing, and obviously like maybe in the small it doesn't sound quite right, but like, you just put something in there just to kind of get a feel for it and write a description, and then have like the human come in and clean it up, saying, okay, like, these couple of beats don't quite make sense, like this is a little staccato here, like we want a different feel for it, or whatever it is, right? And so that would be an interesting way to at least have more interesting music scores for movies. Like a lot of them are just so forgettable because of this very reason.
Yep. Yeah, actually, a couple of thoughts there. So I think similarly, even for images, I think a common complaint that I hear from graphic designers is that their clients will give them very vague instructions like,
Yeah, make it
yeah, I
pop a
like
little
that.
bit.
Yeah, make it pop a little, right? Like that's the thing that everybody like complains about. It's like, hey, I just want a little pop, right? And so nobody knows what that means.
Yeah.
But actually, there's an interesting other demo that I want to show, which is related to this.
Uh-huh.
And so let me just pull this up. But there's another project called Style Clip, which allows you to do something very similar. So basically you can give it an input image and then you can give it little nudges in the direction that you want it to go while still maintaining its input. So you can say, well, here I have a picture of Mark Zuckerberg and I want Mark Zuckerberg to have a tanned face.
I see.
It'll actually generate that. And you can even make it do all kinds of stuff. So you can say, I want my Mark Zuckerberg, but with a completely different haircut.
Right.
And then this is actually my favorite, Mark Zuckerberg with a troll face. And so you can use Clip to kind of steer an existing image more in the direction that you want it to go. And so kind of going back to this point of you have designers, let's say, produce something, but then the client comes back and says, make it pop a little. Well, maybe actually Clip can learn what it means to what people mean when they say make it pop, and you can give it an image and you say make it pop, and it'll do something, some magic, which will be a little bit of a popified version of the input image.
I can see that as a one feature website where you upload an image and it'll pop it for you, just as kind of a joke website. That's pretty interesting. One of the things that I forgot to mention in terms of applications of this technology today is also in crypto. Like our guy Suhail running Mighty, like he decided to have a side project in which he wanted to release NFTs of song titles. Like that's all it is. It's AI. So he used a generative model to generate like song titles, and he wrote them in the smart contract explicitly. Like he handpicked the most interesting ones, and then those are minted as an NFT. And then because the NFT is shown as an image and it looks like it looks like, so you can see that that's the he calls it the Tunes project, and it looks like a little MP3 player with different, it looks like a player and the titles. And so effectively, like it's just generated song titles. And what's interesting about this is he managed to amass a community that has some energy behind it, because then people were motivated to create actual audio based on the title, and then create new NFTs that are tied to this NFT with the song title, with the actual music. But also the part that's relevant here is that there's other projects in which they use the text of the AI generated song title to generate the cover art.
What are they using for this? Are they using the Clip plus GAN method?
I mean, from the looks of it, it looks like it, but I don't know for sure. Like I didn't know Clip existed until, like, I saw the page, but I didn't read too deep into it when it was on Hacker News, and so I wasn't sure. But it looks like it's something like Clip steered GAN of some sort.
Yeah, it has that. There's a certain quality to it. I can't put my finger on it, but it definitely is like that.
Yeah, so like you're so cold, I'm so hot, and it looks like there's a face here and some coldness and some fire going on over here, right? Like these definitely look a little bit like when you zoom in, some of the details, like it's almost impressionistic in that sense. When you look in too far, like some of the details don't make sense, but zoomed
Right.
out, you're like, oh yeah, I can see what's going on there. So
Interesting.
yeah, this is pretty cool. Like this is one way that crypto and AI is intersecting right now. And so I thought I mentioned it before we moved on to like the second, third order effects of whatever we were talking about, like the possibilities.
Yeah. Yeah. I mean, I think the commonality between clip and these types of models and crypto is that basically they lower the barrier to entry. In that, I think crypto lowers the barrier to entry in building the energy and excitement around these things and also monetizing them. And then clip lowers the barrier to entry in the creation of AI tools. And they kind of almost becomes Legos at this point, where you can take clip and plug it with some other thing and generate these very interesting mashups.
Mhm.
And so then if you mash up clip plus these crypto communities and these crypto tools, then you basically are combining Legos upon Legos into these very, very interesting combinations of AI and culture. And so, yeah, you're getting kind of AI generated album art. I'm sure AI generated music, and music NFTs are going to be a big thing, people say. And so, yeah, I think it's just kind of accelerating the pace at which these things can be generated and the pace at which these things can be monetized and become part of our culture.
Yeah, it's strange in the sense that these generative models and like clip, they are only able to map to that latent space because of all the stuff that's on the internet currently, and it's almost like a statistical snapshot, I guess, high dimensional statistical snapshot of our internet culture at this point in time.
Yeah.
And so when we write a description to steer it, it's almost as if we're just looking through a straw to like peek at different parts of that culture at any one time.
Yeah.
And I could see that you could perhaps every decade or maybe every 2 decades train another clip GAN combination, and that would be the zeitgeist for that decade, so to speak. And so you could kind of take I mean, as they stand today, I think it would be more a tour of like a dreamlike zeitgeist of our culture. But maybe if these things can generate more coherent pictures rather than like a dreamlike, because like definitely like we said, the cover art, for example, for Tunes Project has kind of this abstract dreamlike quality. Like maybe we can train other things that feel more like an actual place. And I guess you could actually have something generate like 3D worlds too, right? It should be possible to do that, or for a description to generate a short clip or perhaps a movie. I'm not sure how far you could take it.
Yeah, I'm not sure that our current machine learning models are able to maintain enough context over a sufficiently long time that they'd be able to generate an entire movie or even an entire song.
Yeah.
But definitely the building blocks of building a beat or building an instrumental track, or similarly for a movie, maybe generating a little bit of a dialogue or an opening sequence or a few. Actually, it could be interesting to generate from an idea a kind of a storyboard, because this is an intermediate step that people do when they're building a movie. Is they take a high level concept and then have these drawings of individual shots that they want to compose into a scene. And so maybe you could take clip and you say, I want an action sequence, or I want
teenager teams up with 60-year-old to travel back in time to potentially almost sleep with his mother, right? So
yes, exactly. And maybe if you had started with the right training data of this kind of thing, you might actually be able to have an AI generated storyboard of that from which you can pick and choose the ideas. as you please.
Yeah. And so that should lower the cost of production. Albeit, I don't know that the cost will be passed on to consumers. Like movies will just be as expensive. But like, I think if anything, that could help the ideation and lower the risk of more indie movies, right? Because I think studios now know that a lot of like indie movies have the potential to be base hits. Because like a lot of times, like movie studios, they pour so much money into movies, and that's why they're conservative with it. And so that's why you get a lot of like Marvel comic like type of stories, because they know there's an audience for that already. It's relatively low risk and high ROI, but there's a lot of possibility for stories out there that aren't being told, and we only have so much attention. And sometimes like there are things that take people by surprise. Like Seinfeld was at its time like a weird kind of sitcom, because it was about not a family, people that are completely selfish. There's no lesson at the end, nobody learns anything, and they talk about like life's most inane things, right? Like it's I'm surprised it got greenlit at all. But like when that happened, like it kind of changed the landscape of sitcoms. And reality TV with Survivor did the same with the landscape of TV, but it took like people to do that shift. And so if you could have generative models that people can play test, not just, like be able to run through different ideas pretty quickly, but also play test them with focus groups too, you might get like quicker shifts in the type of stories and story formats and programming that are available to us. And that would subsequently change culture. And I guess, as with the previous episode, I forgot which one we were talking about with TikTok, like culture is just moving too fast. I guess the DAO.
Yeah, I think that was the DAO one. Yeah.
Right. Yeah. And I can see this also accelerating that, where I guess at the end of the day, like I will not know any reference of what anybody else is talking about. And I think that's like that today. Like a lot of times I'm like, somebody asked like whether I wanted to do a collab on Instagram. I had to look that up because I was like, I don't know what that is.
Then you're hopelessly unprepared for this world of
right, apparently, right.
No, but I think you're right that lowering the barrier to generating media, whether that's generating images, video, music, and maybe combining all of them together into a show or a movie or something like that, lowering the skill required in order to put something out in the world is going to mean that there are lots of people with very good ideas that they might not otherwise have the connections or the skills or the network to be able to produce something like that. Now we're probably going to see a ton more of those ideas coming from all over the place. And they're going to be using these AI tools to put something out in the world. And so, I think that the traditional things that are used to gatekeep the creation of things is going to slowly erode. And there's going to be a ton of interesting ideas that otherwise would not be ever considered saleable. The other thing that I actually want to explore a little bit.
Before you move on to that, I guess one quick addendum is that like when the gatekeeping goes away in one place, it ends up shifting to another place. Like we're not saying, at least I'm not saying that it'll be a free for all. Like when you have a free for all, you do get a lot of really bad people doing, like people that are not should have no business making media, I guess, doing that. But it's okay because like the storage of the internet is effectively infinite. So by all means, more power to you, right? But it is that like once you get that sort of deluge or like proliferation of media, I think it'll follow the same pattern as internet, where then aggregators become more important, because then people's problems as consumers of this media is, how do I find the good stuff, right? And so there has to be a way to surface that sort of stuff.
And these are kind of cycles of removing the barriers and then reconsolidating and in a different thing.
Bundling, unbundling, so on and so forth. Yeah,
exactly. So I totally agree with you there. the direction that I want to explore a little bit
Yeah.
is the idea that all of these things that we're talking about, Clip and DALL-E, can be steered using natural language.
Yeah.
And so what it also means is that it requires very, very little technical sophistication in order to interact with these systems.
Mhm.
And I can imagine that the goal of computing, or at least a certain set of computing people, has been this idea of end user programming, that somehow the programming languages and programming tools that we build are going to become sufficiently simple that the average computer user is going to be able to modify the computing environment that they interact with. And now, computing aside, I think that these models are also going to open up the idea of end user media creation, in the sense that maybe it's possible in the future you can take a song, just a song that's released by an artist, and then as a user, as a consumer of this media, you can say, I want a little more drums, right?
I want more
drums.
More cowbell is what you're going for.
Cowbell.
More
That's right.
Yeah,
Yes. And so, you can take you can take a hit, and then what if you are able to use clip steering or whatever other steering method with a different model to say more cowbells, and now you have a personalized version of the song. And so you start with this base song, but you have this end user customizability aspect that wouldn't otherwise be possible, because you're not going to go and put this into audio editor and then put a cowbell track on there or something.
Man, I guess there's so one thing that came to mind immediately as an aside is it would probably be a wellspring. It's going to be like a sub specialization of copyright law to kind of figure all this out. Like, can an algorithm own the media and the images that it's generating, or is it the person that's steering it?
Yeah.
Those sort of questions. My guess is probably going to be the latter, where people think of the neural network as a camera, and the creative aspect is the person pointing the camera or typing in the description.
Yeah.
But then on the other hand, the pattern of the DAOs is the pattern given by DAOs runs against the grain with that, because it is the DAO that owns the finances and the generative art. It's just that collectively people vote on it. And so if you can register DAOs as legal entities in Wyoming, technically are they legal persons? Like,
yeah, I think so. Yes.
Yeah, they're legal persons. And so maybe in that way, AIs can be legal persons through attachment in DAOs registered at the state of Wyoming.
Yes. I'm sure I said it in the DAO episode. There's going to be lots of interesting court cases that are going to be litigated about this.
Right. And so that was the thing that immediately sprang to mind. So like some of the second and third order effects is maybe people need to like start going to law school today to kind of catch this wave later on, right? Because I know that when I graduated college, like lots of people ended up going into finance and consulting, because at the time, like it wasn't fashionable to be an engineer. And then as it became more and more fashionable to be engineers, all these people came out with law degrees that like, I can't find a job. So you really just need to get ahead of the curve and see that this stuff is coming, I guess.
Yes. Yeah. So I think actually if anybody listening is interested in law or is a lawyer looking for some type of career change, I think that being a crypto lawyer, whatever we're talking about, is probably going to be lucrative down the line. Yeah,
even taxes, like the crypto tax thing is still like not quite set in stone. I mean, I have a friend that does taxes, and well, maybe let's cut this part out because I didn't have like that sort of stuff, but I tell you about that stuff later. Anyway, so Three, two, one. And so that's pretty interesting. I can think of like other types of problems Clip and DALL-E would help solve, like small problems, I guess. One of the things is selling concepts to people that are decision makers but aren't creatives. And I find that a lot of times you need to show people stuff because they just can't picture like whatever it is that you're telling them. And like I think my communication style tends to be more abstract, and I've had to adjust that style for people that like concrete examples. And so one way that I think might be interesting is if you can use this technology to sell either movie or music or like art concepts to executives. And so you just kind of type like, okay, like we haven't done the work, but this is maybe what we're thinking. And so you type it in, you kind of click on things that are along the lines of what you're thinking, and then you show it as part of your PowerPoint to an executive or something, saying kind of, this is what we were thinking. And you can generate like 4 or 5 of these within an hour or two without having to like spend a day Madman style for a pitch, right? And like fly over there, and you got like one idea, and if it doesn't work, then you're shit out of luck.
Yeah. I think that goes back to this like idea of just being able to put more out in the world, and as a consequence of putting more things out in the world, you're able to explore the space of ideas and potentially have better ideas just by being able to start out with more ideas.
Yeah, and the parallel with our very first episode with thinking tools is that the thinking tool guys premise for computing as a thinking tool is that our tools aren't responsive enough to help us think in the way that humans readily think. But in their scenarios, it's always that it's you with yourself, and the computer is really just the medium and a facilitator. Whereas here it's markedly different. The computer is not just the room or the facilitator or the space in which you're doing your thinking with yourself. It's a co-collaborator, right? And that's a really different way to think about how you might use computers. Like Alan Kay and who's the logo guy? I forget. The guy that invented the logo programming language, his name escapes me, but it may be forget it, whatever his name is. Like they always conceive of like computational thinking as, oh, you have this iteration with yourself, but through the computer, and the computer needs to facilitate it with like really responsiveness. Whereas this is like the computer is like somebody, a co-collaborator that you iterate with and you push back against, and they push back against you. And that's something new. That's definitely something new.
Yeah. I think that's actually a better way to phrase it. I was specifically talking about programming and end user programming. But yeah, generally the space of thinking tools, like the vision of computing is that the computer becomes your medium, but then, like you're saying, the computer also is now able to take an active part in giving you ideas, surfacing ideas that you otherwise wouldn't come up with yourself, because it's consumed this massive corpus of data. And so it's able to show you things you might not otherwise been able to do. And then at the same time, you're able to steer back with it. And it does tie back to that very first episode, because we were talking about thinking tools specifically for note-taking and building knowledge graphs. And we did come up with this idea that it's possible that in the future, you'll have these distributed collaborative knowledge graphs in which some of the actors are AIs, right? And so they might be able to produce some types of text that then you build on top of, or you modify, or you reply to. And so, yeah, similarly, I think in the space of generating media, tools like Clip, again, become these active players which you can riff ideas off of.
Yeah, it's a strange world, especially once again, like maybe the more episodes we do, the more we can reference ourselves, right? So if you have yeah, could you have voting members that of a DAO that are AI, and they would be able to make a creative argument for like why they want to vote one way or another, right?
Yeah.
That because they you could conceivably generate that sort of text, and I guess the latent space might be the goal, I guess, or like what they would want to have happen, and then the text that gets you that goal is like what really persuades other humans and gets most votes.
Yeah. I could definitely see that. Yes. Yeah. So it'll be interesting. It's kind of like Star Wars, right? Like where you have droids, and droids are like they're not quite human. They are what they are, but at
Yeah,
the same time, they like are taking active part in negotiations the piloting of not planes, but the spaceships.
X-wings, right? That the DAO raised for them, which is what
Yeah.
we. Yeah. Oh man,
Yes.
I cannot wait until we have so many episodes that we're just talking about our own episodes.
Yes. I mean, the last thing that I do want to discuss is the you brought up this idea that you're able to maybe generate objects. I think that's where you're going, like maybe in the metaverse.
Yes. I
Okay.
didn't want to go too
Okay.
far there, but yes, effectively, because like one of the tough things about 3D modeling with our computing platforms right now, I find that people have a really hard time translating the flatness of the screen to a 3D model. Like for whatever reason, like I remember like people that are our parents' age, like that generation, they had problems like mapping the plane of the mouse to the plane of the cursor with the plane on the screen, right? And so like there's a little bit of that coordination issue, and I find that lack of mapping also exists for people working with 3D objects. So unless people are like industrial designers or like 3D animators, like they have adapted to the tools and their brains like work well in that way. But like most everybody else really have a hard time with it. Like even if they see the 3D object and they can like move it around, it's not intuitive to like manipulate that object at all. And so the point is that 3D authoring tools are just really, there's a big learning curve. It's not really for people to use in the same ease that people can write with a keyboard. And so I think one of the things that would result with tools like this is it puts creation of 3D environments and 3D authoring tools in the hands of regular people so that either they can type out a description of what they want and iterate on that description until they get a 3D object that they can then 3D print. Or I guess if AR and VR glasses take off and there is a place, whether it's Roblox, Fortnite, or something else, where people can generate their own in-game items that or clothing or avatar, then that would be a version of self-expression. So you could conceivably in a game write an entire backstory, descriptive backstory about your character, and it would generate its skin for you. And that can be pretty interesting. And so the programmers themselves don't have to create like every individual item there. Like you just leave it up to the AI to generate those things, like within some bounds. Obviously, you don't want people saying like I wear a giant gun as I wear a howitzer as an arm or something like that, and that's very fashionable. And so
yeah. But I mean, I could definitely see that if you have some space in your game, like a house or something like that, you could decorate your house in a very unique style that you wish to by generating one of a kind objects. I could also see potentially in that future, we talked about in the metaverse, there are some people in like the Philippines or something, who are like grinding
Yeah.
to get like some kind of items and selling them.
Yeah, it was in the DAO episode. It's called the Yield Guild, and basically it's a DAO where they are making investments in digital real estate in the form of NFTs and digital in-game items in the form of NFTs. And so people, as a part of the DAO, would grind through these games to earn the NFTs as part of their membership and work earning for the DAO.
Yeah, so I was thinking that if you're able to generate these in-game objects, custom in-game objects, there might be a market for very unique ones or very cool ones, and there could be people who just make a living off of using these like clip steered 3D generative models to generate interesting pieces of furniture or interesting cool looking weapons or whatever, and then generate one of a kind objects which then become highly coveted in these in-game markets, and people might actually be able to make an entire living creating objects that don't even exist.
Yeah. Do you know if there's a standardized set of weights for clips? Because it's only trained on the open source one is already pre-trained, right? And so I would imagine, well, so one of the things I was thinking was NFTs are quite limited in the amount of data that they can store on chain, and for various good reasons, it's expensive to write chain because in order to write on chain, you have to change the state of the blockchain, and that means all the nodes that are participating need to change state. And so obviously you want to make that more expensive to write the state because the state is recorded forever, right? And so that means that NFTs don't actually usually store the image of the NFT on chain. Some of them do, like where if it's just text, like the Tunes project, but then there are others that store the SVG on chain because SVGs is just representation of some XML, which is also text. But then kind of the full images, like that, like some of them, like CryptoPunks is 24 by 24. They're pixelated because like that's pretty low in number that you could conceivably just write it on chain, but like you don't get high quality images written on chain. So that's why oftentimes they're referenced off chain. And so I was thinking that if clips and its weights were standardized and long lived somewhere on the internet, whether on IPFS or somewhere else, then if like it's everybody's shared understanding that, okay, this is the neural network model that we're all creating NFTs from, then you could just write the latent vector in the NFT. And then when you look that up, like you just ask the public generative model to generate that for you. And so that's one way of keeping those models available, or the images available. But then I guess the question is like, who's going to run that model and how can you do it in a way that it's like a public good, right? And so I think that can be solvable, and maybe like the weights are written in a distributed way on IPFS or something like that. But like, if you could do that, then that's one way to kind of solve that problem, because a lot of times people have pointed out the disconnect between the NFT itself, which is more like a deed, with the actual like asset of the image and stuff like that. So I thought that might be interesting.
Yeah, definitely. Yeah, I think that they are standardized. I'm sure that people would be able to do that if there's enough interest. But yeah, there is something to be said about having a shared model from which everybody stakes a claim in like one area of the latent space, right? Like that could be a whole fun game in and of itself, of like exploring the latent space of a giant generative model, and then saying, I own this one vector because it produces something cool. Maybe not even just for image generative models, but also for music as well. Maybe rather than buying a clip of like an MP3 of music, you own a vector which then you can feed to this model and will generate something cool.
Yeah, and especially if different things mapped to it. If you own the vector, that means you own all the different versions of that concept in any media, right?
Yeah, I guess so. Yes.
So
And
like
yeah.
you not only own the music, but also the text that describes that music and the image that would describe the music, all mapped to the same vector space, latent vector, right?
Oh, now that's really interesting. Yeah, and yeah, if you had like a very very multimodal model, we're talking about we so far I've been talking about multimodal model in which there are only two sort of modes, but yeah, if you had a really cool multimodal model which could take a vector and turn it into text, turn it into images,
Mhm.
you could like basically you own not just any one piece of media, you own an idea, a concept, which then can produce other types of media.
Yeah, I wonder if that would make licensing much easier, because I was surprised to find that like music licensing is surprisingly complicated. The whole debacle with Taylor Swift re-releasing her own music
Yeah,
and whatnot. Like, we're not going to go into that here. You guys can look it
right.
up on the internet if you want. But basically, like it's just different kind of licensing for different media. And so perhaps if you can like map Taylor Swift to a latent vector space and just own that, like own the latent vector for that area, then that would help solve things. Perhaps. I mean, I'm
Yeah,
just
I wonder if there's a potential. I don't know how this would be implemented, but what if you could own not just a given latent vector, but a latent vector and some radius around it?
yeah.
So you kind of say, this is all my land because I like what's around here. Like, I don't know how this would be implemented. I don't know if people would want to do this, but it's kind of like you're homesteading the latent
Yeah.
space.
And so on one hand, that sounds interesting, but on the other hand, like for certain like public concepts, because like we have established that say like mathematical concepts are not copyrightable or not patentable, right? And
Hmm.
so like the latent space for that should there should be certain things in the latent space that are by default in the public domain so that people aren't like, I don't know, like copywriting or owning the concept of a banana, right?
Yeah, right.
Or the so like one of the reasons why like we even have like the internet e-commerce is because encryption is considered a public good, because
Hmm.
like the people that were for encryption, they're like it's just math, like you can't copyright, you can't patent this stuff, you can only keep it secret at best, but
Yeah.
like so that's how this stuff is available to us. And so it would be a travesty if owning latent vectors ends up at first facilitating a explosion of creativity of people, but then once the homesteading has settled down and like the borders, like people own stuff, it starts to stagnate,
Yeah.
and that sort of stuff happens, right? Where people can't get anything done because like, oh, I want to make a movie about, I don't know, like killer whales and on a plane, killer whales on a plane, right? And
Yeah.
but like I own killer whales as a concept, but not planes, and I have to like fight for that, and nothing will ever get made, right? So I might as well make snakes on a plane.
Right. Yeah. That's a really really weird. I mean, like that's just. I think that's we're here, and then that's like five steps ahead. But
Yeah,
like
that's a while off.
it was, but I think like yeah, it would be very weird if we get to that world. I mean, okay, so I think we have talked about Clip and Dolly. Definitely, we've given it a fair treatment, and we've
Right.
woven this into thinking tools,
Mhm.
DAOs, metaverse. What else have we?
Crypto,
Crypto,
yeah,
just generally not
law,
the,
copyright,
yeah.
yeah,
So it sort of touches upon all of our favorite stable of concepts.
yeah,
But yeah, I mean, I think that all in all, I'm very, very enthusiastic about any tool that allows people to express their creativity, lowers the barriers to entry, of the creation of new things in this world. And so I think that I am, just like I'm not even in the stars. I'm like in the next galaxy over in terms of my excitement for this thing.
Yeah, it's a strange world when I think about it, because like it's almost a different kind of literacy, right? Imagine if you couldn't read or write in this modern world, right? You'd really be hemmed in by the things that you're able to do. And so in the same way, when anybody is a creative, like when anybody can draw just by typing, right? Can draw, can produce media in our media saturated world, it's almost a different kind of literacy where you're now able to produce, and that creates a really different kind of world, for good and for bad. And obviously on this podcast we're optimists. We haven't talked about like some of the weird side effects with like just anybody getting a hold of this, from like state actors with propaganda to like the misinformation going on with different groups. And so that is a weird future that we're headed towards.
Definitely weird. I think we should potentially have future episodes where we do revisit some of these concepts and think through a little bit of the downsides or the risks. But overall, on net, I think I'm optimistic about this.
Yeah, no, generally I am the same way. I think like for all the bad the internet has gotten, like you and I are talking, like Technium would not exist without the internet, right? So I am optimistic as well. So you're in the other galaxy, I'm right there with you. So
very cool. All right.
So this is Will,
and this is Sri.
And we are here at the Technium talking about the edge of technology. If you like what you hear, like shalaka, subscribe, share, like, and subscribe, and smash that like button below, and let us know what you think. And join us next week for even more awesome self-referential episodes where we just talk about the things that we've talked about already. All right. Take care, guys.